Hello Synapse community, my name is Ryan Midgettimer, and I'm a product manager on the Azure Synapse Analytics team. Today, we're going to continue talking about security. If you recall from our last two videos in this series, we talked about the first steps to a foundational framework and infrastructure for your Synapse environment, as well as pipeline security with secrets and key vaults. If you haven't seen those videos already, I highly recommend you check them out on InfoSec Basics and Pipeline Security. Today, we're going to talk about security for your data. So some of these topics are row-level security, column-level security, and dynamic data masking. Starting with column-level security. Let's go to our Synapse Studio and navigate to our Develop Hub. From here, let's expand our SQL scripts section and open one of them. We're going to connect to the SQL Pool 01 database, and then we're going to run each step individually by highlighting the statement in the step in the query window and selecting Run from the toolbar. As you may know, the column-level security feature in Azure Synapse simplifies the design and coding of security in any application. It helps us to ensure column-level security by restricting column access to protect sensitive data. Let's see how this feature works in Azure Synapse. We're going to start by looking at the campaign table by running a simple select star query. Let's also consider a scenario where we have two users. A CEO, who's authorized personnel with access to all information in the database, and a data analyst to whom only required information should be presented. First, we're going to verify that the CEO and the data analyst users exist in our data warehouse. Now, we're going to enforce column-level security for the data analyst user. The sales table in the warehouse has information like product ID, analyst, product, campaign name, quantity, region, state, city, revenue target, and revenue. The revenue generated from every campaign is classified and should be hidden from the data analyst user. This provides Data Analyst Miami access to all the columns of the sales table but revenue. Then, to check if the security has been enforced, we execute this query with the current user as Data Analyst Miami. This will result in an error since Data Analyst Miami doesn't have select access to the revenue column. The following query will succeed since we are not including the revenue column in the query. Whereas the CEO of the company should be authorized to access all of the information in the warehouse. To view the data as the CEO, let's execute this SQL query. We can see now that we have full access to all columns. Now let's check that our CEO user can see all of the information that is present. Yep, just as we expected. The output of this query shows that the CEO user can see all of the information. Let's move on to row-level security. Let's again go to the Synapse Studio and follow the same steps. We'll navigate to our Develop Hub and expand the SQL scripts section and open one of them. Just as before, we're going to connect to the SQL Pool 01 database. And then we're going to run each step individually by highlighting the statement in the step in the query window and selecting Run from the toolbar. Row-level security, or RLS, in Azure Synapse enables us to use group membership to control access to rows in a table. Synapse applies the access restriction every time the data access is attempted from any user. Let's see now how we can implement row-level security in Synapse. In this case, the sales table has two analyst values, Data Analyst Miami and Data Analyst San Diego. Each analyst has jurisdiction across a specific region. Data Analyst Miami on the Southeast region, and Data Analyst San Diego on the Far West region, which you can now see when I run this SQL statement. Say the organization requires that an analyst only see the data from their own region, and the CEO should see all data. In the sales table, there's an analyst column that we can use to filter the data to a specific analyst value. we will define this filter using what is called a security predicate. This is an inline table valued function that allows us to evaluate additional logic. In this case, we're using it to determine if the analyst executing the query is the same as the analyst specified in the analyst column in the row. The function returns 1, will return the row, when a row in the analyst column is the same as the user executing the query, or if the executing query is the CEO user, who has access to all data. Let's review first any existing security predicates in the database. Now, create a new schema to hold the security predicate and then define the predicate function. It returns 1, or true, when a row should be returned in the parent query. Now, let's define a security policy that adds the filter predicate to the sales table. This filters rows based on the user login name. Let's allow a select permissions to the sales table. Now that we've set all of that up, let's test out the filtering predicate by selecting the data from the sales table as Data Analyst Miami user. As we can see, the query has returned rows here for Data Analyst Miami. We can run the test the same for Data Analyst San Diego. As you can see, we've now set up a row-level security framework. Finally, let's move on to dynamic data masking, or DDM. Again, we're going to start in the Synapse Studio by navigating to the Develop Hub and expanding our SQL script section and opening one of them. We're going to connect to the SQL Pool 01 database. And then we're going to run each step individually by highlighting the statement in the step in the query window and selecting Run from the toolbar. Dynamic data masking helps prevent unauthorized access to sensitive data by enabling customers to designate how much of the sensitive data to reveal with minimal impact on the application layer. Let's walk through setting this up. In this case, let's say that the organization has identified sensitive information in the customer info table. They would like us to hide the credit card and email columns of the customer info table for the data analysts. First, let's see the structure and data from our customer info table. Now we can confirm that there are no dynamic data masking policies applied on the columns. We've got no results, which verifies that there's no data masking yet. To mask the credit card and email columns of the customer info table, we'll run this query. The columns are now successfully masked. Now we can see the dynamic data masking applied on the columns. Next, we'll grant select permission to Data Analyst Miami on the customer info table. We can test with the login for Data Analyst Miami and execute the select query and view the result. Let's remove now the data masking using unmask permission. Now, we can revert all the changes back to what they were at the beginning. Well, that wraps up our video for today. We covered column level security, row level security, and dynamic data masking. Do you use any of these things? RLS, CLS, DDM? Tell us about it in the comments. Again, my name is Ryan Majitimer. You can find me on Twitter. You can find Synapse on Twitter, Azure_Synapse. You can find the Azure Synapse Influencer Program at the website in the description of the video. It's very exciting. You should definitely join. Like, subscribe, write lots of comments. Thanks for watching, and we'll catch you on the next one.